Right. This is a question, right? And I want to find out the total current. We all know that the conventional current, जो हमारा conventional current होता है, it flows from,
Positive to negative.
yes, flows from positive terminal to the negative terminal. So this would be the direction of the current, and the current is denoted by capital I. When the current reaches at this point and this point and this point, so the current is going to split up. The total current will split up. Okay. Right. Now, what are we observing here?
Yes.
The four different M meters are connected. Right. The four M meters are connected. तो ये जरा देखना है कि 4 M meters कनेक्ट हैं. तो can we find out the total current? Yes, we can. So we are going to find out the total current. Okay. The current that is flowing through this branch, the first branch, having the two lamps connected in series. ये जो lamp 1 है और ये lamp 2 है, they are in series. So we're gonna find out the total current. And the current that is flowing through this branch is 2 ampere. You can see the ammeter reading. And the current
Yes,
that is
sir.
flowing through this branch is 0.5 ampere, right? So we're gonna find out the total current. As we all know that when the current divides, so it adds up and becomes a total, right? So
Yes.
here, hello, assalamu alaikum. हाँ, I'm taking a class, right? ठीक है, I get back to you. Allah Hafiz. Yes. So we have the total current. We have the total current here, which is 3.5 ampere, right? Now, if this current is not
Yes, sir.
known to us, if this current is not known to us, let's say this is X, right? Let's say this is X,
Yes.
and I want to find out, I want to work for the X, right? I want to find out the X. So how will I find it? See, as I have just told you that these all currents will be added, okay? When they leave the branch, they again get added. When they leave the branch, they again get added, okay?
Yes.
Right? So X is the total current, okay, which is equal to 1.0 ampere plus 2.0 ampere plus 0.5 ampere, right? So that's going to be 3 and 3.5. Okay. So this is how the total current divides in the parallel circuit. Clear? I hope this concept is now clear how to find out the total current when it divides, right?
Yes.
Now I want to discuss that what is the advantage of connecting the parallel circuit. So the components in parallel. If the components are in parallel, right? So you can, control each component independently, right? I can make the circuit that is, that is here we have. So I can connect the switches separately and I can control the each, branch independently, right? Clear?
Yes.
Yes, sir.
Let me call it S1, switch 1. Let me call this switch 2. Clear? So we can control the branch independently, right? We can control the components independently. And as you can see here, if any one component or branch is faulty or is not working, other branches will not be affected. Clear? For example, I can close the switch S1, I can close the switch S2. Okay? The current will only flow through S1 and S2. The current will only flow through S1 and S2, but will not enter S3. Why? Because this switch is not closed. So this means that if the other branch is not working, the remaining branches will not get affected. Okay, right?
Yes.
Similarly, we can also control this uh, the S2, right? The component which is connected in S2. Okay, we can stop them working and we can switch on S3. By closing switch S3, we can allow the current to enter the buzzer, right? So this is how the
Yes.
current enter. Okay, so this is the advantage of having the parallel circuit, right? And now we are going to talk about another concept which is given in this question. Which of these are parallel circuit? Write the letter or letters that are correct. So parallel circuit, uh, you know, each component is directly connected to the supply. You remember this thing. In the parallel circuit, each component is directly connected to the supply, right? Each component connects to the supply, right? Then supply means a cell or a battery, okay? Then that particular component will be considered to be parallel across the cell, okay? Across the cell. वो cell के across parallel पे consider होगा. Right now you can see here this lamp is directly connected with the cell, right? And again this is also connected directly with the cell. So they are going to be parallel, right? Number one. They are not connected in parallel. Why? Because this is connected through the lamp and then make a connection with the cell. So this is not a parallel, right? Uh, they are also connected in parallel. Why? If I say this is actually this is the wire of the component, right? This is the wire of the component. This one. This is the wire of the component. Okay. And this is another wire of the component. So what we have done, we have connected these two wires and they both are directly connected to the cell. They both are directly connected to the cell. Again, this is going to be your parallel circuit. Okay.
Yes.
And
Yes,
what
sir.
about this D1? D is okay, one end and one end. Are they directly connected to the cell? Yes. And one end and another end. Both are joined here and they are connected directly to the cell. So this is also parallel circuit. So if I let me explain this again. If I say this is one, if I say this is one terminal, this is second terminal, this is one terminal, this is second terminal. So that both twos are connected at one point. Okay. And over here, both ones are connected at this point. So this two goes over there and this one goes over there. So they both are parallel, right?
Yes. Yes, sir.
See, in parallel connection, the current has two paths. Okay. The current has the current has two paths, right? So that means if I break this wire, if I break this component, will this lamp continue to glow? Yes. Why? Because the current will still flow through the lamp and then go back. Is this clear? Okay.
Yes, sir.
And what if I break the lamp? What if I break the connection with the lamp? So the wire is broken from the lamp, but still you can see the wire is connected with the buzzer and then goes back. Okay. So there is no,
Yes.
again, there is no effect, we observed if we can disconnect one component, so the other component will not get affected. I hope this concept is clear to you, right?
Yes, sir.
So this one, and this one, these three are in parallel, right?
Yes.
Now here we have another question. Calculate the missing current X in each of these circuits, right? Acha ji. Now we have to work for X in part A. Okay. So I am working on A. Let's do together. If you want to answer, please write the answer in the chat box. Now I want to calculate this guy X. Okay. What I know that the current that is flowing through this ammeter or this lamp, both ammeters are showing the same reading, and these two currents are get added at this point because the current goes back, okay, and it enters the branch and then leaves the branch, right? So it enters this ammeter, which is known as X, okay. So what we are observing here, that X is carrying both of the currents. The X is carrying both of the currents, therefore the answer is going to be 2 ampere. Why? Because this 1 ampere, yes, good. So 1 ampere plus 1 ampere, that's going to be 2 ampere, right? This is how you will get the answer. What about this part B? How will you find this X? The current starts from here, enters the branch, and then remaining current enters the branch. So we can see here the 2 ampere current is flowing. So they again get added when they leave the branch, okay? So they get added and enter the ammeter. So this ammeter will show the total current again this time. So X is going to be 2 ampere plus 2 ampere. Ampere is the unit of current, right? So you're gonna get 4 ampere current, okay? Now what about this part C? You can see here the current starts flowing, right? And then it enters the ammeter. So that's going to be our total current. Okay. After flowing through the total current, when it reaches here, so that total current splits up into the branches, right? So here we have the three branches. Okay. First current goes there, the remaining one will go there, and the remaining leftover will go and enter in this branch. Okay. So we can see here this ammeter shows 1.5 ampere, this ammeter shows 1 ampere, this ammeter shows 0.5 ampere. They again get added, okay, and then they come back, okay. So this a ammeter, which is known as the X point X, so what we know that what we are observing that uh, this will show the total current. So the total current is going to be the sum of all the currents, okay, through each branch. So are we going to add? Yes. So 1.5 ampere plus 1.0 ampere plus 0.5 ampere, right? So what are we going to get? 2 and 3 ampere, 3.0 ampere, right? Okay. What about this part D? Okay. Yeah. So part D, as you can see here, the current starts from the positive terminal, which is known as conventional current. We call it capital I, 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 right? Now this total current, okay, when enters over there. Now, do we have any current here since the switch is open? Therefore, we won't get any current, right? we won't get any current here, and you can see the ammeter shows zero reading because no current is entering here. Therefore, 0 ampere will be there, right? Now the current will continue to move on. It enters at this point, and that's going to be 1 ampere. Okay, and the remaining current will enter at this point, passing through the buzzer, and it shows 0.5 ampere. And then again they get added here, and it will become the total current, right? So the x, the ammeter shows uh, 1 ampere plus 0.5 ampere, right? So that's going to be 1.5 ampere, right? So this is how you do the calculation, okay, and find out the total current from the branches, right? Okay, now here we have the question number 5. And this question says that calculate the missing current X in each of these circuits. Um as we know that this is going to be your total current, right? Which is 6 ampere. 6 ampere starts flowing and reaches at this point, it splits up. And when it reaches here, it splits up, right? So what are you observing? That this is a total current and it divides into two branches. Clear? So in the first branch, what are we going to write? The equation. Can we write the equation? Yes, 6 ampere equals to, because this is 6 ampere is the total current, right? 6 ampere equals to X, okay, which is the reading of ammeter. And here this is the 3 ampere. Clear? Now what are we going to do? We will shift this to the left hand side. So we get 3 ampere current. Let's talk about the B1. Again, when you see this, the total current starts flowing, which is 1 ampere. It enters the buzzer, it enters the lamp. Okay. So again, we are going to write the equation. How are we going to write the equation? This 1 ampere, 1.0 ampere equals to, that means 1 ampere is going to be divided into the buzzer and into the lamp, right? So how will you write it? 0.4 ampere plus X, right? Now this time you will shift this 0.4 to the left hand side. 1.0 minus 0.4 ampere. So you get 0.6 ampere. So I hope that you people have understood. Make sure that whenever you write the answer, never forget to write the unit, okay?
Every single part of the case that it was happening, and then, well, then I need to go and factory was the
All right. Now what about the part D? Sorry, part C. Let's do the part C one. In C, we can see here the current starts flowing. It enters this branch. It enters this branch, right? We do not know X current. It's fine. But what we know that when current leaves the branch, so they get added, right? They get added. So this is going to be your total current in this circuit. 0.3 ampere is the total current. So the total current, let's write the equation. 0.2 ampere plus X ampere equals to 0.3 ampere, which is the total current. Now, in order to find out the X, you will make the X subject, shift this 0.2 ampere to the right hand side. 0.3 minus 0.2 is going to be 0.1, right? This is the answer. Now, let's do the part D one. As you know that the current starts flowing here, it splits up in this branch, it splits up in this branch. Oh, it doesn't split in the over here. Why? Because the switch is opened. The switch is open, right? So there's no need to include this one, right? And then it enters this branch. So it enters X and it enters this lamp and they get added again. clear, and they add up to 0.25, clear. So the total current that we got is 0.25, which is going to be split up into 0.15 ampere and in the x. So in order to find out the value of x, we shift this 0.15 to the left hand side. What are we getting? 0.25 minus 0.15. It's going to be 0.1, right? Yes, 0.1 ampere. Okay, thank you. Or you can also write 0.10. All right. Now we're gonna do question number 5. Another question here. Zara has a series circuit with 9-volt battery, a lamp and a buzzer as shown in the diagram. The voltage across the lamp L1 is 2 volt. As you can see here, the voltage is 2 volt here. That means if I connect a voltmeter, so the reading that is shown by voltmeter will be 2 volt, okay? The reading will be 2 volts if I connect this voltmeter across the lamp, okay? Across the lamp. Now, I want to calculate the voltage across the buzzer. What I know that this is since it is a series circuit, right? This is a series circuit, one after another. There's the current has only one path, okay, to flow. So current remains same. The total current will remain same. That means whatever the total current is there in the circuit will have to flow through each component equally. Okay. So current remains same, right? The next thing is what divides in the series circuit? Voltage divides. Okay. Voltage divides, right? Across the component. Clear? Across the component. Right? Now, what is the total voltages, which is known as EMF? What is the total voltages? EMF equals to total voltages, and total voltage over here we have 9 volt. Okay, we have 9 volt. This 9 volt will be dropped in such a way across the lamp it is 2 volt. Okay, across the lamp it is 2 volt, and across the buzzer it is going to be, how will you calculate the total voltages minus the drop one? How much drop is there across the lamp? 2 volt. So you will subtract the 2 volt from 9. So you will get 7 volt across the buzzer. So across the buzzer you got 7 volt. Now Zara adds another lamp L2 in the series with other components. State what happens to the voltage across L1. So see, uh, if you if you add another lamp across this L1, right? And she's saying another lamp, right? L2. So what will happen to the voltage drop? The voltage drop decreases. Clear? Across the L1. Okay, across L1, voltage decreases. Okay. So that to keep the total voltage same, right? Because we are not adding the cell or battery here. Now in the part 2, state what happens to the current. Because when you add load in the circuit, the total current decreases. Okay, you can add yourself.